In this section, you will classify triangles by the sides and angles and also find the measures of their angles. So let's look at the diagrams. In the first triangle here, none of the sides are equal to any of the other sides, so we call it scalene. If we look at the angles of this triangle, this one seems obtuse. So this is a scalene triangle based on the three sides being unequal, but it is an obtuse triangle based on the just one angle being obtuse. Next, if we look at this triangle, these two sides are now marked congruent, so it's called isosceles. And in this triangle, all the angles are acute, so this is an acute triangle. A triangle with three sides equal is called equilateral. Equilateral is also equiangular, and the angles measure 60 degrees. So equilateral is also equiangular in a triangle, and the angles measure 60 degrees. We have a triangle which is a right triangle. Right triangle cannot be acute or obtuse because it's a right triangle. A right triangle can be scalene or it can be isosceles. For example, if I have a triangle like this, that's right, and these two legs are congruent, then it's right isosceles. In a triangle, it is useful to label the angles as being in the interior or the exterior. So how do we identify the interior angles of a triangle? Well, let's first of all highlight the triangle and color it in. So now, any angle that I mark with an arc, where the arc is in the yellow, this is an interior triangle. And in the next diagram, the exterior angles are marked by whatever is outside the triangle, not in the interior. So let's go ahead and mark those. If this is an exterior angle, and this angle vertical to it is also exterior. We call it exterior because this exterior angle is formed by this one side that is being extended and another side, and same thing over here. Okay, so similarly we have this. Okay. So we have this angle and this vertical angle, they are exterior angles, and over here we have this one and these are all exterior angles, the angles marked in blue. And it's useful to remember the exterior angles. An exterior angle is formed in a triangle when you take one of the sides and you extend it. So this angle here is an exterior angle. You all know this triangle sum theorem. All it says is if this is angle A, this is angle B and C, then the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. The sum of the interior angles of a triangle is 180. Interior angle. So let's just say that here. Interior angles add to 180 degrees. Exterior angle theorem. What does that say? It says if I have an exterior angle here, that one there, so let's call this A, B, C, and we'll label this point D. Then the measure of angle ACD equals the sum of the two remote interior angles. Remote means that those angles are not adjacent to angle ACD. So the non-adjacent angles that are also in the interior are these two angles A and B. So measure of ACD is equal to measure of angle A plus measure of angle B. Let's take an example and see how this works. So let's make up some numbers. Let's say this is 30 degrees and this is 50 degrees. Well, then angle C is equal to, or the measure of angle C is 180 degrees minus 30 degrees plus 50 degrees. So the measure of angle C is 100 degrees. So that is this angle. Well, if this is 100 degrees, then the angle next to it, angle ACD, the adjacent angle, is that 80 degrees equals 50 degrees plus 30 degrees. So an exterior angle equals the sum of the two remote interior angles in a triangle. The corollary to the triangle sum theorem pertains to right triangles. So let's mark this triangle as a right triangle. Let's call it triangle A, B, C. So if angle ABC is 90 degrees, it stands to reason that the measures of angle A and angle C are also going to be 90, because the three angles must add up to 180 degrees. Okay, and measure of B is 90, so if we, instead of B, we substitute 90, we get measure of A plus measure of C equals 90, and we can say angle A and C are complementary. So how do we use all this information to solve for angles, given triangles, and given parallel lines? So here we have two parallel lines. I'm going to highlight those, and I can see an angle that's marked 42. So I am going to mark my transverse. So I'm going to make it a little longer. Aha! I see here alternate interior angles. I've got a Z. So the measure of angle Y is equal to 42 degrees. And that's alternate interior angles. Now, look at this angle marked 65 is the exterior angle for this triangle. Let me mark that. So therefore, if I call this angle Z degrees, using the exterior angle theorem, 65 degrees equals 42 degrees plus Z degrees. Subtract 42 from both sides and you get Z degrees is equal to 23. So Z is 23 degrees. Well, if Z is 23 degrees, then Z is an alternate interior angle to X. Therefore, X is also equal to 23 degrees. So there you solve for X and Y. Just a reminder, when you have parallel lines, remember to isolate the transversals. Okay, you have a triangle within a triangle. Actually, you have quite a few triangles here. So let's look at what we are given. I see a right triangle, and I'm going to highlight my right triangle just so that I can see it visually, see it better visually. Okay, there is my right triangle, and I know that x degrees plus 19 degrees plus x degrees plus 19 degrees plus 90 degrees is equal to 180, and therefore if you do your arithmetic, x will be 71 degrees. So I've got x here, and then I've got x degrees, 32 degrees, and I am going to highlight this. Ooh, that didn't work too well, did it? So I've got this triangle that I'm going to look at, and this. I notice that y is the exterior angle of this green triangle, and these two are the remote interior angles. So y degrees is equal to 32 degrees plus x degrees. Well, we know x is 71, so y degrees is equal to 32 degrees plus 71 degrees, and y degrees is equal to 103 degrees. Let me see, I need to find x, so x is in this triangle here. Not getting my highlighter to cooperate. Okay, that's better. Okay, and what's more, this is one of the angles of the highlighted yellow triangle. So in this right triangle, I can say x degrees plus 19 plus 34 degrees plus 90 degrees equals 180 degrees. So I get x degrees plus 53 degrees plus 90 degrees equals 180 degrees. So you get x degrees plus 143 degrees equals 180 degrees. Subtract 143. Subtract 143, and you get y degrees is equal to 737 degrees. I think that is correct. So let's do a check. 37 and 46, 56, 59. Looks good to me. Alright, so I've got my y. Okay, so I'm going to mark it here. Oh, no, I don't mean I've got my y at all. I mean I have my x. Okay, so x is 37 degrees. Let's just fix that. That's messy. Okay, so this is x and x degrees. So I know x is 37. I'm going to go ahead and I'm going to mark it here. 37 degrees. How does that help me? Okay, let's see. So this is the angle I want to find. This is y degrees. Alright. Well, if I knew this angle, so I'm going to put a question mark here. If I knew this angle, I could find y, because those two angles will be complementary. And this angle is congruent to this angle here. So can I find that angle? I think I can. So let me go ahead and highlight this triangle. There's a right triangle here. Okay, and I'm just going to work off to the left hand side here.